I'm Anthony Woodward. I'm the CEO and one of the founders here at RecordPoint. Today we've got a very interesting concept in conversation with Jason Franks talking about ChatGPT. And Jason is one of our long-term engineers here at RecordPoint, but more importantly, he's our lead data scientist. Do you want to introduce yourself a little bit more, Jason?
Thanks, Anthony. So yeah, I am, as Anthony said, RecordPoint's principal data scientist. My job basically involves anything to do with software architecture, with data, and particularly around AI and machine learning. I'm a technical person. I spend most of my day looking at code and drawing architecture diagrams. So apologies for any lack of polish in today's chat, but I'm sure Anthony will keep me in line if I start going off on a tangent.
Oh, you might have to keep me in line with going off on tangents, but that's all right. Look, I thought we'd introduce the topic today because the reality is everybody has been talking about ChatGPT, Bard, if you've gotten into the Google sphere. There's 4 or 5 other flavors that we're going to talk about later. And hopefully most people here on the webinar have had a chance to use it. It is a disruptive set of technologies. It is certainly a set of technologies that is looking to really change the way we work over the next 10, 15 years. But Jason, it's not a new set of technologies, is it? Would you be able to kind of put in the layman's terms really what this AI sphere is, and then we'll bring that together around what ChatGPT is in that realm?
Yeah, thanks, Anthony. Look, AI is a big umbrella term, and I hear a lot of people using it to mean different things. So I thought it would be good to just start with some sort of definitions of what it is, because AI in itself is a really broad area. It's a subdiscipline of computer science, which has been around since the 1950s. So again, it's not new, and it's about getting computers to solve problems in a human-like way. Which means without you needing to have a programmer who's going to tell it step by step what to do. So this is typically things like learning or inference, generalization, deduction. There's 2 main schools of AI. They are the symbolic school and the statistical school. So the symbolic school is much more interested in deductive logic, right? So being able to get the computer to reason with facts and with numbers, and to be able to make logical decisions that are really easy to trace and follow. This school has, there's been different times where the symbolists have been more popular than the sort of statistical AI type of people. The symbolist stuff is really good because it's really efficient and it's really intelligible to a human. You can understand how the machine has made its decisions. Right now we're kind of seeing the statistical type of artificial intelligence coming to the fore. So this is where we're looking more at probability. So instead of saying I want to explicitly model the logic and perhaps the maths that underlies this decision making, we're going to try and learn from example. So we get lots of examples of whatever process it is that we're trying to model, and we learn from that observation by trying to generate a model that is going to be the one that is most probably going to give you the correct answer. Right. So this is machine learning based on stats. Now I think that this one has kind of come to prominence recently because of firstly the increasing amount of computing power that's available, with the cloud and with improving hardware, and also the increasing amount of data that is available. Again, also due to the internet, everything being online, it's much easier to process that and use that to train a machine learning model, which can be used to to predict or to classify or a number of other sort of similar tasks. So we have AI as an umbrella category. We have the 2 schools, symbolic and statistical. Machine learning is a type of statistical AI, and then we come to neural networks, which is it's a machine learning algorithm, which is kind of designed. It's inspired by the human brain, and what makes this different to the other machine learning algorithms that we've had is that they often rely on some sort of elegant mathematical formulation, whereas a neural net is really crude, but it's really big. And the power of it is that you can really scale it massively to learn from a lot of information, to handle high dimensional data, which is data where there's lots and lots of variables. And this has been what has enabled, I guess, the new, the sort of new revolutionary large language model and the generative AI that we're starting to see really change the landscape today.
No, and it's great, and so all the hype is really around ChatGPT and the 3 flavor and the 4 flavor and the rest of it. I think it's worth unpacking even that acronym. Everyone says ChatGPT as if it flows off the tongue, but what does that stand for?
So it stands for Generative Pre-trained Transformer. Generative because it's able to generate text, not just predictions of a single variable. Pre-trained because it has been pre-trained on massive amounts of data scraped from the internet, and transformer, which is the name of the architecture, which I guess has been used to embody this type of model. There have been other pre-trained language models that have had different architectures, but this has been the most successful one, going back to Google's BERT 5 or 6 years ago, and leading to the current generation of large language models, which we can kind of see on this slide.
And ChatGPT is from an organization called OpenAI. Now, it's worth probably, I think, the audience understanding, because you talked about our model, but when we talk about Bard or we talk about ChatGPT from OpenAI, there are actually many models, aren't they? They're not just one model.
Yes, that's right. So OpenAI has a whole suite of different models that they have that you can use, ChatGPT being one of them. Meta has numerous models as well. Bard, I guess, is Google's consumer-facing transformer model, which I guess is intended to have similar capabilities to ChatGPT, but they have a whole suite of other models as well.
No, great. And what we have on the screen here is a series of different players. Can you explain the difference between, and we've seen this out in the marketplace, people talking about Jasper and Write versus the Bard and Meta we have at the top, because they are quite different in implementation.
Yeah, so Jasper and Write and Perplexity and these guys, these are more like applications that have been written using the large language models that have been provided by OpenAI, by Google, by Meta. So under the covers, they're using that same technology, but they've used them to develop a number of different AI-related technologies, depending on which company we're looking at. And then Hugging Face right in the middle there is a open source project which gives you interfaces that kind of generalize access to some of these models, and not just the 3 that are listed there, but there's probably hundreds of open source large language models as well.
Now, in all of the cases, I find them a lot of fun as a chat box to connect into these large language models, and it's obviously a bit of a focus in our presentation today around LLMs and how they come together. Do you have a sense of how many parameters are in ChatGPT 3? Just to give the audience, I think, a sense of just how big these models are.
I think it's billions. I have the number somewhere. ChatGPT 4 has billions of parameters. Each node is something like 90 dimensions. So they are massive. And I think that's
my understanding is ChatGPT 3 is about 175 billion, and GPT-4 is 100x that. So it's just mind-boggling the number of parameters inside them.
And I mean that's how they work, right? That their scale, I think, is the secret of success. One of the secrets of success here. The first being the way that they're trained. So there's a bit of novelty in the way that these language models get trained, where we've the companies that have built them have recognized that there's masses and masses and masses of text which they can use to learn information about how language works out on the internet, but there's no outcome. So traditionally, when you're trying to train a machine learning model, there's an outcome that you're trying to reach. So that's where the pre-training comes in. They've trained these models to understand language from those huge amounts of data, and they that can then be used as to front load all that knowledge into whatever application that it is that you want to use your language model for. And they're really powerful, right? They are able to answer questions. They're really strong at manipulating text. They generate output that feels natural, like it's grammatically correct. It sounds like a human has written it. They're really convincing. And under the covers, what they're doing is it's all probabilistic, right? So it's going based on this sequence of inputs. What are the most likely outputs that this user is expecting? So I guess what I'm trying to say there is that they're really convincing because they're trained to be convincing. Like they're trained to give you what they think that you want by dint of understanding.
It's worth noting that they don't really understand language, do they? Whilst it appears that you're able to have a conversation with them or give them a prompt and for them to return something, they don't actually understand the semantics of language.
Yeah, they understand, like, I guess understand is a questionable kind of construct, but they know the way that the words work in context, and they can distinguish between, for example, homonyms, where you might say, for example, the word bat. So the word bat has many different meanings depending on what sentence you're using. Like it could be a cricket bat, it could be the animal with wings that flies around. It could be that you are battering some fish. That's a part of that, but it could also be that you're the batter in cricket, right? So they can recognize that the words are different depending on the context, but they don't have a way of really understanding. They don't have knowledge and they don't have an experience of the world. So everything they're doing is a kind of a trick, right? It's a trick to kind of go, this is probably what's gonna come out based on what it's seen before. But they're not able to reason. They're not able to do ordinary logic. They're not able to add. They can't do mathematics. They just know what that looks like. So they know that if you say if A and B then C, like they understand that that's a construct in the way that people might talk or people might write something, but they don't really know how to make that calculation. If you try and ask it to add two numbers, if you go 1 + 1 =, it knows the answer is going to be 2 because it sees people saying 1 + 1 = 2 a lot of the time, but it doesn't really understand how to add. So something to be aware of, I guess, is if it looks like it knows something, it's because it's kind of memorized something, and it might get it right or it might get it wrong, but you can't rely on it for decision making. You can't rely on it to do calculations.
Yeah, and because of that does bring some risk, right? There are issues with accuracy because its depth of what it has been trained on tends to be historical as opposed to current. The sourcing of that content is not easy to verify and is not entirely traceable. But is there other risks we need to think about as we're using this tool?
Yeah, look, just to kind of reiterate, like they're designed to be convincing before accurate or truthful, and you can't rely on it as a source of knowledge. Sometimes it's going to give you a correct answer, and sometimes it's going to make stuff up, based entirely on some probability calculation, but it has no way of like knowing what is the actual truth. That's got to be something that we can establish by the way that we use it, rather than by relying on it to know that. So I don't know, did you want to talk about hallucinations, or did you want to?
Well, yeah, no. So I was going to ask then. The result of that often is, hallucinations and other things, and we'll come to that. But because of those factors and the risk there, there's been a lot of hype in the market about how, these generative AI pieces are coming for our jobs, and we're all going to be replaced next week. But the reality of what you just talked about, and what is still an early tool for us to use, it is still just a tool, and it's not really going to replace us. It's just going to be another assistant that we can use.
Yeah, look, the quote that I like is, as with any new technology, I can't remember who I saw this attributed to, but they said you're not going to be replaced by a language model, but you might be replaced by someone who knows how to use them,
No, absolutely. Now, knowing that, and knowing the bubbling up of some of those concerns, one of the things that we've heard a lot about, I think, in the marketplace, and I think the audience will be aware of, are there are biases in the model, and it's something to be really aware of as you start to leverage these tools inside your organization. What are those biases, and how can we think about dealing with them?
So, all data is biased. Like it's a sort of fact of life in the data science sphere. But I think what people maybe don't realize is that bias is not necessarily about what text has been used to train the model, or about the content of that text, right? It's not typically things like, the model's been trained to have some sort of racist or sexist or that kind of understanding of the world based on its read documents that are, it's been trained on hate speech or something like that. A lot of the bias just comes from distribution, right? So sampling bias, I think, is a key one here. So an example of that might be that, let's say we want to use a language model to filter resumes. We're a HR function at a business. We're going to say, I'm going to use this language model, or really any machine learning tool, to I'm going to train it using successful candidates that I've had come through the system, and then I'm going to use that to decide which candidates I'm going to interview further. Now, you might, for example, be in some sort of like maybe a male-dominated industry, maybe like software, and the model is going to see. You're going to train it with resumes, and it's going to see that the majority of successful candidates are male. So nobody's going to told the model men are better at this job than women, but it's going to kind of see that because probably the majority of candidates have been men, not even successful candidates, right? And that kind of bias is going to weight the way that the model is going to perform without you telling it to do that. So this is the kind of thing that we have to be really careful about when we use, I guess, any kind of machine learning tool. It's that correlation versus causation fallacy. And this is one of those things that I don't think it's a fixable problem, other than you have to be careful. You've got to watch what it's doing, and find ways of counteracting that, which may mean being careful about how you select the data. But a lot of bias is not coming out of the content of the record. It's coming out of the proportions of records saying particular things, which are used to train the model.
Now, each of these, when we talk about ChatGPT and we talk about specific implementations like Bard, they do have ways to rebalance some of those biases, don't they?
Yeah, so there's different ways of doing it. You will have seen a lot of the time that language models will give you information about, we'll try and tell you things that they're not able to talk about a particular subject, or certain subjects are offensive. I think this is because Meta released a language model towards the end of last year that was generating hate speech. They tried to take it offline very quickly, and now the vendors have been very careful about building in guardrails to try and prevent that. But they're not perfect. There is a subset of people around the place that are working. Have kind of made a game of circumventing those guardrails. And we're now starting to see, for example, Elon Musk is now saying that with his new AI startup, his models are not going to be politically correct. They're going to only be truthful, which is, nonsense, because these models are not. They don't understand truth. They just understand what is the most
Spoken like
probable
a true engineer.
Yeah.
I guess that brings us to not just the notion of bias, which is ultimately a reflection of the data a model is given, right? A lot of those biases just come from data sets, and data sets have biases. So whether or not it's a conversation about ChatGPT or AI, any data modeling or anything that we're dealing with statistical probability is going to have a biases based on the data that created it. Like that's, and then there are weights and measures to correct that. But something that's very unique to ChatGPT versus other styles of information management style technologies, which are quite because they're a basis of a program language that has a set of rules, and you run through those rules. They're pretty reliable in the outcome that you're getting. One of the things that's very unique, and we've seen a bit of this, is as the models are getting better and better, and they are really getting better and they're fun to use, they do hallucinate. I've seen it. Jason, have you seen much of that?
I have, and it's quite funny. If it'd be funny if it wasn't so concerning, I guess you'd say. I've seen some really good examples where, for example, I guess the classic one was, which they've now kind of fixed in a bunch of the models, was you could ask ChatGPT to tell you about the first female president of the United States, and it would go on and fabricate a whole story about Hillary Clinton's presidency, which obviously never happened. It can be more subtle than that as well. I've seen GPT fail to recognize a painting by a particular artist, where it recognizes other paintings from that artist, but it'll tell me that the one I've asked about doesn't exist. I've also seen it fabricate information about a particular scientist that I asked it about, including telling me where the scientist works and contact details for that person. It's all fabricated, right? It's just, the model has said, well, this is probably some output that's going to satisfy the user, but it's not real, right? And part of the problem is that it'll do that, right? It doesn't know that it's lying to you because it doesn't know what the truth is.
No, that makes sense. So let's get to a little bit deeper into the topic then for today. I guess that's the background and the context of those things. I think it's really important to bring that together. But as we start to talk about that in a records management world and the application of these things, how can we leverage large language models? What are the processes here, and what are the opportunities that come out of it?
So I think that we in the record space have a kind of unique position in that we have access to all the records, which are the truth, at least which we hope are the truth. And this is the way that you can make these language models reliable, right? So understanding that whatever data was used to train the language model, it's a model for language. It's not a source of information, a trustworthy source. But you can use that to then extract information from like what are actual records. So Microsoft calls this grounding. So if you find the source of truth in your records and then provide it to the language model in the prompt and say, go and find me answers, go and find me information in this text, then it's much less likely to hallucinate, and it's probably going to give you correct information. So there's heaps of stuff that you can do with it. Not trying to treat it like it's Google or some sort of a database or a source of knowledge, but by saying, I have the source of knowledge. Here it is. Now go and do tasks on that for me. So we could use them to enrich record metadata by potentially pulling out the names of people or places or other information that's in the record. We can do sentiment analysis. We can train it to classify records for disposal, retention, or whatever other sort of classification, whatever other ontologies we want. And for me, like, I think one of the more powerful things that we can do with it is we can use it to summarize. So I can say, here is a 1,000-page report. Give me a 1-paragraph summary of that, and it'll condense that data and give a pretty good summary of what's in that report. And then I guess the other thing that I think is a pretty cool application is I could then you could be a bit more freeform about it, right? So you could say, using a sort of chat style interface, maybe like you see if you use ChatGPT or Bard, on a particular set of records, answer questions about it. Now, those records, again, they could be thousands and thousands of pages worth of information. And this is a really good way of reformatting that information, condensing it, or getting it to extract knowledge out of it without you having to potentially read all of those thousands of pages. Now, I still recommend that you fact check it. So if you get some information out of it, then it's probably a good idea to go back through the actual text and see what it is. Verify that what it's saying is correct. But it's really good at that, and it's reliable. And I think this really gives us the ability to understand records at scale that we've never had before. Sorry, that was a lot.
No, and I think those applications that we've certainly been seeing with the integration to provide classification and better prediction of control is really automating that up. And I know that's what we're going to get to in our demo and show some of those capabilities there. But there's a rich metaphor within the information management and records management community to really look at better summarization, better classification, but more importantly, doing that en masse at scale in a really rapid way by integrating to those tool sets.
Yeah, look, I mean, there's other tools to do some of these tasks, and some of them are really good. Some of them are really competitive. Definitely, they're cheaper than what a language model would cost you to do it. But from my research, I found that they tend to just be a little bit better, a little bit stronger. So if we talk about classification, for example, which is, I guess, a bread and butter task for records management, the sort of older style machine learning techniques that we would use, in a platform like our records and data trust platform at RecordPoint, it's a bag of words technique, which goes, it looks at the records, tries to find what are the most important words, and then it's going to create a model that says, based on the proportion of these words inside this text, I predict that it's going to be X category. Now, the large language models have a much better understanding of what the words mean. It doesn't just scramble the words into a set where it's going to count them. It recognizes what they mean in context, and they do perform a bit better. But it's an increase of 2 or 3% accuracy versus probably 100 or 1,000 times the cost. So you don't always need a large language model to achieve these results, but for some of them, I think they can be quite a game changer.
Yeah, and one of the questions I saw flow through the chat there, and certainly one that I've always been interested in, as you leverage large language models, and just to clarify, ChatGPT is one form of large language model, as is Bard, as is some of the others we talked about at the beginning. But leveraging one of those large language models, does that mean I'm exposing some of my data through this process? Because the opportunities here for records managers is that they'll be able to leverage it, improve the summarization, improve the context of the data. What am I sharing to achieve that?
That's a great question. And the answer is that it kind of depends. So if you're a consumer and you're using, the free version of ChatGPT or Bard, or even I think the paid version, anything that you feed it is going to be used by Microsoft or Google potentially to train future versions of the model. So if there's private data or personal data, or there's anything that is protected or is not allowed to leave your estate, your network estate, or potentially the country in which you live, that's bad, right? If you're a corporate customer who is using these offerings at scale, they now have offerings where they'll guarantee that your data stays in your tenancy, it doesn't get shared, it doesn't get used to train anything else, it stays in the region that you allocate for it. And this is stuff that they've come to market with pretty quickly through the start of the year. Once the technology started to mainstream, and I guess people said we want to use this, but data privacy and security is important to us, and we can't just let you have it.
No, great. And I guess that for and we're going to show you just in the moment some implementations of these things, but for the average user out there, there is a whole bunch of different capabilities that can be leveraged. So here at RecordPoint, and we've been working with AI for 7 or 8 years now, embedded in products, but we're starting to leverage the large language models as an extension of that AI. So really looking at providing better summarization, better custodian tools that can rely on freedom of information requests, FOIA, FOI, depending on what jurisdiction you're in. There is some concerns around extending the data sets into these large language models. So there's tooling that we're providing in that space to better control the intellectual property issues and the data management and governance issues that link to that. So that there's better filtering of that on those protocols. And that is, I know, a strong concern in this industry of, this is a great tool with large language models, but how do we leverage it that way? And then lastly, providing, having the skill sets and the capabilities to validate those outputs and understand their context. So there is a number of different slices on this to deep dive, and certainly here at RecordPoint, we're providing deeper tooling and happy to engage if anyone wants to understand those things better, so that you've got control over those integration points with the large language models out there. And when I say large language model, that's ChatGPT, it's Bard, and 30 other flavors that you're going to see come onto the market in a little while. One of the things to think about in this space, and I'd be interested in your thoughts here, Jason, is there is some procedural changes around how you're collecting data and the type of data that you want to send back to the large language models. What are those that we want to think about that provide that context?
So, I think your classic information security is still relevant here, and is maybe still the most important thing to think about, especially if you're actually going to be attempting to train some of your data into the language models. Again, you probably don't want to do this for information retrieval purposes, but if you want to be able to classify or whatever based on data that's in your corpus, it is possible. It's been shown going back to 2020 on GPT-2 that those models were trained with personal information, and it is possible to get it to get some of that back out. They've found addresses, contact details, group membership, a variety of things like that, which are concerning. So I guess which functions are available to which people. That's the number one thing I think to secure. You probably don't want to give all of your end users free access to any language model that's been fine-tuned with your private records data. Also, probably another thing I should mention is that even if these vendors are keeping your data and they've locked it down to your tenancy only, and they're not going to use it to feed any of their other models. OpenAI got hacked earlier this year, and in a situation like that, you have to regard them as another vendor that is potentially keeping some of your data, and I guess understand the security risk there. So even if the data is not available publicly through their models, if they get hacked, some bad actor could potentially still access it. So all of these are things that I can consider.
As information management professionals and as engineers, Jason, we're always taught to look at the risk, but there is ways to mitigate that risk to make sure your data isn't being shared in particular ways and stays on your side of the firewall. Those are the tools and techniques that I think are very important for this industry to understand better, because we want to look at what data is transitioning beyond the boundaries that we have into that public LLM space, if possible.
Yeah, absolutely.
So what's that?
So I was just going to say, you know, like with any machine learning, like the actual, you know, developing the machine learning part of, you know, a sort of application like this is the easy part. The security, the integration, managing all those processes, that's the real challenge. But you know, that's what engineers are for, right?
Yeah, and look, it's worth saying all those vendors, be it Google, be it OpenAI, be it Microsoft and Azure, they're all going to have their own private playgrounds as we move forward. They've all made an announcement in that space, and you know those are the integration points that we're also seeing and engineering towards in your daily work. I suppose that brings us to the next point, Jason. Why don't we actually show the audience some of these pieces and how that links together? There, you know, and then we'll get to some of the questions.
For sure. So I've got a bit of a proof of concept, which I've built into our, you know, records and data trust platform here at RecordPoint. This is not production code. This is not an offering that we have at the moment. It's just intended to give you a feel for how some of this might look if it's integrated into like a records management platform. So let me just share the screen.
And I think it's worth saying, Jason, that what we wanted to share with the audience is directionality. We are working with all of our customers and happy to work with the entirety of the community around these different integration points. What we've seen is certainly a need with a number of our customers to provide some deeper depth, and that's certainly what Jason's showing you here is those elements. I mean, for those that don't know, what Jason has on the screen here is Records 365 out of the box, and we'll show you those integration points where you can leverage this in your everyday world. To be frank, forget that it's Records 360, that it's out the RecordPoint Data Trust platform. For a moment, you know, these concepts really can apply even if you're working in a spreadsheet. A little bit more manual, but would be possible to do in that construct.
Yeah, look, I could do this demo out of, you know, ChatGPT front end, but I think it's a little bit nicer to show the records management system.
Right? I mean, I think it's really important to talk about, Jason, here that the large language models are you know, all these different flavors. So there's a few different flavors of integration here.
Yeah, and you know what I'm going to show you here is actually using a couple of different language models under the covers, but it doesn't really matter, right? All right, so to the demo, I have loaded the Enron data set into this environment, and let's say that we're pursuing a freedom of information, or we're doing some sort of data forensics in this record set, and I'm interested in looking at let's say corruption. So I might start off by saying let's find some records that talk about, you know, corruption or the Foreign Corrupt Practices Act, which is maybe something I'm particularly concerned about violating. All right, so I found some records. Let's see. Now, what will have happened here is, as we've ingested these records, as they've, you know, come into the environment from whatever content source they've been at, we crack all the text out of them. We peel off any metadata. We add new metadata to the record as well via various sort of enrichment processes. And then what we're going to do is we're actually going to pass the text of this record to an OpenAI model. This one's using DaVinci, which is not ChatGPT, but an LLM like it, and ask it to summarize the text of the record. So let's see what that looks like. So here's a summary of the text that was in this document. This email is from these people discussing the potential risks of payments made to receive informal customs advice, which could be a violation of the Foreign Corrupt Practices Act. So that sounds like something that's worth investigating. I don't know about you, but that sounds pretty dodgy to me. So let's do that. Let's go and have a look for that record. I'm just going to pull it up in this view. So this is our record that we were looking at before. And I'm going to ask a question. So you can consider this maybe something that's a bit like the ChatGPT front end or something like that. So I might start with a simple question and say, I don't know how much text is associated with this record, but let's find out some information from it. So my first query is going to be, which people are referenced in this text? So you notice I put in this text. That means I'm not just asking it invent a bunch of people or tell me what people you think might be associated with, with anything. I was specifying in this text which the platform is going to provide to the language model as part of the prompt. So it is sending all that information to, this is the ChatGPT model here. This is GPT 3.5, and it's going to tell me these people are mentioned in the text. Okay, so now I know kind of who potentially is involved in these issues. So I might now say, what kind of corrupt behavior is discussed in the text? Right, so what are we really talking about in this record? Now, I've only used one record here, but potentially, I could have selected 10 or 20 or 100 records to ask these questions about. So now I'm asking GPT, based on this text, what are some examples of corruption that you can find here? Corrupt behavior discussed in this text includes possible payments made to receive informal and favorable guidance on customs issues. These payments may be legal, but maybe indicating potential corruption. Mention of fixes, which sounds pretty dodgy. And so, this has given us a pretty good summary of what could potentially be like huge amounts of text. I think at present, these language models can deal with about 25,000 words in the prompt. At the start of the year, it was 5,000, and I expect that amount of text that they can deal with is going to keep on growing. I might try something a bit more specific as well. So based on the summary of dollars at risk is the name of the document. How much money is at risk in this text? $180 million. So that's a pretty substantial amount of money. If I'm a business who's interested in finding out about risks that are undertaken by potential illegal activity, or I'm some sort of a royal commission or government agency, trying to establish if something bad has happened and what the extent of it is, this is a pretty amazing tool. Right? It could take weeks for a record manager to read all of the documents that have come up as hits from my initial search, but I've got some pretty good information here. And again, it's pretty easy to fact check it. I can go and take this back and I could, potentially search in that information. So what is $180 million? And then, see where it's come up with that figure. I can tell you right now, it didn't calculate that by itself. This is a figure that will have come out of the text. Right? It's not going to do, arithmetic for me. It's not going to do decision making, but it's pretty good at, pulling information, pulling answers out of, a substantial amount of text. What do you think of that, Anthony? Can I ship it?
No, it's great. It's great. The other element in here, is just then being able to not only capture the record itself, and I think I saw it in the chat, but we can also then retain these inquiries. We can retain the processes that link to that, be that in an upstream system, be that down here in the data trust platform, the RecordPoint data trust platform. So you got real flexibility of not just understanding the context of the inquiry on the individual piece of information here, but also the inquiries that have been made over it. It's worth saying, Jason, for the demo, we've just selected one document because it's kind of simple and easy and makes the point. But in reality, this is probably going to be a collection of documents about a topic or an inquiry or an investigation, and we're going to come from multiple different systems, and we're able to bring those together to then ask these same questions. I think that's what's very cool about this is the ability to slice and dice that data from some Salesforce data, from from Office 365 data, etc. Retain the questioning, but look at the data set through a large language model lens.
Yeah, the nice thing about doing that, as opposed to relying on data that's been trained into the language model, which again is not reliable, is I could give it 100 documents, ask it a question about all of them, and I could tell it to tell me which document that information came out of. So it can narrow that down for me, right?
And so that's what you're really getting internal traceable AI, because whilst the large language model is assisting us to break this data set apart, what we can now do is help you to go, what was the source of that individual piece of data that you're stretching on? So that, for example, the 180 million, it would then bring you back to this document, which is a really powerful element inside your organization. You know, many of the attendees here from Australia and possibly even around the globe will be aware of things like the robo-debt inquiry and the robo-debt processes. What this would give you the ability is to look in and see what the model is that's linked to that, and what's the piece of data that's going to drive these answers and questions. And that's going to avoid some of those scenarios. Now, there's a lot of depth to unpack behind that point, but it does give you that moderation, if you will, of your internal IP against the large language model. Now, whilst this is, as I said, in this example here, we're sending it out to, in this case, ChatGPT, could be Bard, doesn't matter. You know, this is something as things roll on that will be inside your landscape, inside your firewall, so you're not sharing that data. And there are rules around how to set that up and do those things.
Yeah, 100%.
And in this case, with the example you've got, Jason, we're not allowing ChatGPT to learn from the data we're sending them. So you've set that up in your settings, and the data that's transferring across those boundaries isn't being used to retrain ChatGPT. And that's a commercial relationship that is there in place.
Yeah, that's correct. That's correct. I mean, I think, like, if you look at anytime there's a discussion of service levels around freedom of information in any government agency or you know, anywhere around the world, you know, if you look at any of that, you start to see that everybody's failing at it. Nobody's able to do it. Nobody's able to serve the information in a timely way, or they just can't find the information. And I think this is a this is a real game changer in terms of being able to do that.
Cool. Is there anything else you want to share with the audience, Jason, or shall we move to questions?
I think let's go to questions.
Great. So we have had quite a few questions come in, and some really great conversation I see going on in the chat. Absolutely want to see if we can address a number of the things that have come up. And if we haven't, please reach out to us directly, and we're more than happy to have a one-on-one conversation or just do it over email and those sorts of things. So quite a lot of questions coming out around the legal perspective and the concerns around privacy, confidentiality, and intellectual property. What some of the real core issues of working with LLMs in their current form. I suppose, knowing, Jason, that their current form is going to change, I'd like you to put your crystal ball in a little bit. Where do you see that going to, and how do we give our audience some of the tools to better work inside those constraints?
Oh, look, I think the majority of it comes down to that recognition of what they can and cannot do. In terms of, you know, the inability to reason, the inability to be truthful, that inability to do calculations, and just ensuring that any time that you know, we ask for something from a large language model, that we ground it in the truth, like we give it some data to give it a fighting chance of being able to some data to analyze, as opposed to just assuming that it's an oracle. I think that's kind of the main thing. Does that answer the question?
No, absolutely. And I'd probably just add to that, Jason, that, you know, when we talk about confidentiality and intellectual property in those elements, it is about understanding what you're sharing. It is about understanding those privacy issues. As I said a few times, there is different technologies, and one of the things that we've been doing, and a lot of our customers have been quite interested in our beta programs, is looking at what are documents that have PII or PI, depending on the jurisdiction we're in, so privacy information in them, and then restricting those from being passed through to the large languages and the models. So the example that Jason gave was from the Enron data set. The people involved in it are tagged as PII, but they're not internal in the organization or high risk. So we were able to go off and make that inquiry. But the reality is that we want to protect elements of that data, and so that there are ways to certainly do that and make sure that that information isn't flowing upstream and downstream. It is worth saying the licensed models with Bard at Google, with ChatGPT at OpenAI, and there are various flavors of that, are something for you to unpack and have a look at, because those licensing models do have different controls, and there are 4 or 5 different models just within those different systems. Some allow retraining of data, some do not, some have other variations on it. You pay the top dollar version, which is expensive today, but we expect will get cheaper as time goes on. You can have no data shared, no data retrained, but that is an expensive option. One of the things that we really looked at is who owns the information and how does it relate to the data. What you saw in the example that Jason just did was the information is owned by you. It lives with you. Whilst we're passing it over very simply to get an answer constructed, ownership never changed. And it's very important to look at the tooling there to retain that ownership and the capabilities there, and how, what that is then going to relate to the rest of the data inside your corpus. I don't know if you add anything to that, Jason.
Yeah, look, I think what we store as well, what you index is really important here as well. So like in our platform, for example, we have technologies to pull credit card numbers and other ID numbers and that kind of thing out of records. We typically then don't index that information. So we'll flag this record contains payment card information, for example, but I'm not going to make that searchable. And having a user having rights to be able to find that information and see it can be controlled that way, right? So you just have to be really careful, I think, about not just like what you're finding in there, but what you're surfacing it and how you make it available to the people who have access to your platform.
There's another question there about where are the servers located. I'll talk on the data trust platform side. We have servers located on the RecordPoint side in each of the key jurisdictions, Australia, an extension out into New Zealand. The US is a completely autonomous zone, Canada's autonomous zone, Europe's an autonomous zone, UK's autonomous zone. But when we talk about the LLMs, where's their data, Jason?
Again, it depends which offering that you take up from whichever vendor that you're using. If you're using a vendor and you're not hosting the models yourself, but again, Microsoft and Google have now both made it available where the model will be hosted in your region. Maybe not all regions are supported yet, but they will be. So again, depending on how you set it up, you can make sure that it is hosted. If all your data has to stay in Australia, it'll stay in Australia.
Yeah, and you mentioned it before. There's been some data breaches at OpenAI. What are the protocols and cybersecurity that you can expect? I mean, this really is just another service from Microsoft, another service from Google. It's kind of the same, isn't it, as the current procedures you have with those vendors?
Yes, I guess OpenAI was an acquisition by Microsoft, so maybe it's not, as fully secured as most of Microsoft's offerings, but it will be, and it'll be the same, exactly the same procedures that you have to broach if it's Optus or any other provider gets hacked. And
yeah, just to clarify something, Microsoft didn't buy OpenAI. They just invested into it, so a slightly different paradigm. It's actually a different business.
Well, as they brought it into their into Microsoft Azure, into their cloud environment, they have a pretty strong security game with Microsoft, and I expect we'll see that hardened up pretty well.
If ChatGPT is building new processes and making recommendations, it's effectively almost creating some intellectual property. And so there's a question here around who owns that new intellectual property that comes from the thing after the summarization? And I know this is a brand new field, Jason, so the answers aren't clear, but what's your understanding of the current landscape?
Oh, look, anything that's created by an AI is not copyrightable. But also, like, if you store it inside your environment and it's not available outside of there, then I don't know that IP law is going to kind of come into it if it's not accessible. It's a pretty big deal at the moment, this whole discussion, especially, I guess, given that these vendors are, or particularly OpenAI, are refusing to disclose what data was used to train the models, and people are wanting to use it for commercial purposes. But yeah, look, I think if you're not planning on copywriting the summaries, for example, that get generated, then you're probably all right. Again, I'm not a lawyer; I'm a data scientist, so this is not legal advice. This is my opinion.
Yeah, no, look, I think it's fairly well researched opinion anyway. But there's guidance coming from various government entities around the globe. I've certainly been involved a little bit on the periphery of the Biden administration's advice around AI and some of the things that have been happening in the US. Jason, are you across what's happening in Australia and New Zealand and the various advice points? I know we provided some feedback to them at different stages.
I have not heard anything back from at least the government here in Australia. I know that they've got a initiative going, which is like across many departments, going from intellectual property to privacy and security. But I'm not aware of any policy that's come out of it yet.
Yeah, that's right. I put you on the spot there. The Department of Industry and Science did put out a submission paper, and we published onto the website our responses publicly to that around the responsible use of AI and explainable AI. We did a similar piece to the Biden administration in the US, and I believe there was also some guidance from the New Zealand government. So again, we will circulate post this presentation a series of different links that talk to some of those things. There's some really interesting elements that different governments are doing, thinking about the regulation of these technologies and how the data works. So how do you store it with data sovereignty? How do you know the controls are there? What are the various elements that link all that together? One of the questions here is, can AI scan our data environments and learn what's a record and what's not a record? And I think that's a great question to probably finish on today.
Wow, that's a big topic. Yes is the short version. Does that AI have to be an LLM? I would say probably not for a lot of it. A lot of it you should be able to tell just by looking at, if you've got good metadata about your records, you'll be able to sift through a lot of the, what's right and what's not, just based on looking at things like, draft marks and file sizes and file types. Certainly, I think an AI element will make that more reliable and perhaps give you kind of more fine-grained result, especially if you've got different things in your organization that might constitute a record versus not a record. And again, I don't think you could go to a large language model and say, is this a record or is this not a record, without training it in some way. So all the tools are useful in making that disposition, but I don't think there's like a single answer. I think it's got to be a kind of mix of technology.
No, fantastic. No, and thank you very much, everyone, for spending time with us today. Really appreciate you attending the webinar. As we said, we will send out a copy of the webinar. If you have more inquiries, you'd like to know, pick Jason's brain more, feel free to reach out to us. We're more than happy to provide some more context, and really appreciate you all hopping online and spending an hour with us. Have a great day.